Hello YouTube again. I haven't made a video in quite a while, about 2 months to be exact. But this is going to be another update on this wheeled robot right here. This robot, you may have seen the last video on it was like in March or something. Right now it is August. So in that time I have done quite a bit of work onto it. You could see right here that I replaced the motor controllers. These used to be relays. Now I replace them with proper DC motor controllers. These are the IBT2 motor controllers. You can see right here they are motor controller H bridges. Basically what they do is they can control the motor so it could go in either direction, and it could be controlled by pulse width modulation. So we are getting an upgrade from the relays which were in there previously that could just turn it on and off at full speed. Like you may have remembered in the last video I did about this, there was a problem with the relays, is that when I use them, they once again could only go on full speed in either direction. This created a problem as the motors, they would spin way too fast. If you might know, these are drill motors. I have 4 of them, so it has way too much power. It would go way too fast. And I thought I could solve this problem by undervolting them. But for whatever reason, when I tried that, these motors wouldn't really like it. 2 of them would spin, 1 of them would spin slowly, that kind of stuff right there. So I replaced them with these motors, which can be controlled via pulse width modulation. So rather than lowering the voltage, I could slow them down via pulse width modulation so they could be controlled and have a lower speed but still have the same voltage. That should work better. These motors are controlled in the drill with pulse modulation. Here's the drill trigger. Basically what this does is when you squeeze it, it creates a pulse width modulation between these 2 wires, and that drives the motors. You can see that I wired it up to the main power bus right here. And this is just temporary, just so I could test it with a drill battery. I have done some testing on it. I probably won't do any testing right now, just because I have to wire up all these motor controllers. I've only tested it with this one. You can see that it's the one which is wired to. I have an Arduino Nano right here, just on a breadboard. You can see these are the old motor hubs. I replaced those, but these are the old motor hubs. These are the hubs which I was going to replace with the 3D printed ones. These ones are made out of plastic cutting board, like this one you see here. But these 2 squeeze in a breadboard which has an Arduino Nano in it. This Arduino I am going to use to drive the robot, at least for its initial testing. What I want to do is I want to have it have the same obstacle avoidance program that my smaller robot has. So I'll put an ultrasonic sensor here, and it will run into walls, well, hopefully back up before then, and turn around, which is what it would be programmed to do. It'll be running the same program as the smaller robot, except modified for these larger motor controllers. Other modifications that I did, speaking of these wheel hubs, I replaced those with electrical conduit covers. This is one right here. You can see that this is the bolt JB welded onto a piece of aluminum rod. This piece of aluminum rod goes through the wheel. You can see it ending right here. And what this does is it keeps the wheel centered. So the wheel is centered onto these 3. These are number 8 size screws. 8, yes, they're number 8 size screws. And these are secured on there, so it is secured with these bolts. They are bolted on the other side as well. And it has the center JB welded. The thing with the JB weld is that it would break if I would twist the wheel either way. So that's what these bolts also prevent that as well. This just maintains that it's centered. I did that on all 4 wheels. You can see that I used this electrical conduit. The electrical box plate cover, which is what this is. The reason I use this is because it could be tapped, and the threads which I tapped into it will not strip like the ones on this one do, which is just plastic. This one has a bolt. This one has a nut going through it, which is also metal, so it will stay in place, but it's very thick. So that's the problem with this one right here. These I got away with because they are thin and they can also be tapped easily. You can see there are some washers which I made out of some of this, not that, but I made washers out of this, which is just a metal bar that I drilled out, and one of them is tapped, one of them isn't. So basically what I could do is I could tighten this onto this and tighten the bolt and tighten the nut right here onto the shaft of the motor, so it's 3 threaded ends tightened onto each other, so that way it should move just fine. When I was using these attachments, or these ones, the robot, it wouldn't really balance correctly. It would kind of wobble when I did that. You can see how I did here. The robot is stable. When I move it, it moves, and it doesn't bounce up and down like that. So that isn't quite an improvement over what we had previously. I redid the power connectors. You can see that it goes through a positive and negative bus, and that goes through all the motor controllers. And when I'm finished with this, it will also power the Arduino. But I don't have that right now because that would require a step-down converter, which I don't have. What I'm going to do is I'm going to replace this cutting board, which everything is mounted on, with this much bigger one. This will allow for more mounting space. I could mount all these motor controllers, this bus bar, and I would have more board area to mount the Arduinos, and I also have room for the batteries and other equipment which would be on this rover thing. And yeah, you could see what I tried to do with these motor controllers. I mounted them with zip ties. They are tied on this end and also on the other end on the bottom. It works okay, but it does wobble. You can see I cut one out of here just because it wobbled so much. I want to replace these with proper bolts, but the only kind of bolts that will fit are number 4 size bolts. I do not have those. I tried with these number 8 size bolts. I tried with number 6 size bolts. Neither would work. It needs a small size that I could get at the hardware store. And when I try to do that, these holes probably aren't exactly aligned for a bolt to go through. They have zip ties going through them. Zip ties are made out of plastic, so they're flexible and they could fit through any hole that I can fit them through. So that's a lot of the reason why I have to redo it onto another board, just so we can make sure that there are more precise holes. Also here you can see the zip ties on the bus bar go around the bus bar through 2 of the holes on it. So there are 2 holes in this cutting board for each of these holes. So obviously when I want to mount it, I would have to have it just a screw going down right there and bolt it on the other side, which I can't do that because there are already screws there. So this was just a real quick video just to make sure I have something to upload. I will update more later. Also, I did quite a bit of work on this robot. And that's it for today.